we actually have to develop the two equations now. So we're not just going to like, here's equation 1, here's equation 2. You have to develop them from the word problem, okay? That's the only difference here. All the work and all the practice you've done with substitution and elimination still applies here to find x and y. We kick it up. This is about the final notch, okay, where we just give you words. You turn those words into equations and then solve. That's it, okay? So I guess the point of this lesson, this is like kind of the pivot point for the mechanics of substitution and elimination, and then actually like the finesse of word problems, right? This is the pivot point. So we'll discuss here, okay? We're just going to come up with like a list of common words used to represent mathematical operations, basically, is what we're going to come up with here. You can use this list to kind of, when you're reading a question, you should be thinking, oh, like sum is addition, or the word is equal, or difference is subtraction, things like that, okay? So that I'll show you how to, first couple will break down, and then you'll get the hang of it. You might not need to do it that way all the time, okay? So some common words for orders of operations. What do you, like, let's just start with the addition, the plus sign, okay? What's some common words that you would associate with addition? Is it cold? A little bit. What's some common words for addition? Adding, sure. That looks like a D. Sum. What else? You guys think of any more? Sum plus.
What was the last thing you wrote?
More. Sometimes you'll see like there's examples of it down in the bottom, but so and so has twice more than somebody else, something like that.
Wouldn't that be
Yeah, it can be, but it's the way that they use the word more. So it's the context that they use it in.
yeah. Like yes, 10 more.
Yeah, 10 more than somebody else, right? That would be addition. Okay, everybody okay? And then subtraction. What are some common words for subtraction? Difference would be probably the most common one, I would say. Well, if you were reading word problems all the time. Then you got things like minus, take away, sure.
Lose.
Yeah, lose or less. Okay. Or the word fewer. It's always good to do this with students because you guys have different terminology for stuff, right? Like I have 4 here, but doesn't necessarily mean it's the lingo that you guys use, right? Because that changes all the time, right? Are there any others? Okay. What about multiplication? Product is typically, I think that's kind of what they call multiplication, and when you're learning it for the first time, 2 numbers multiplied together give you a product. Okay. That's not even on my list, interestingly enough. Times, twice.
I mean, I guess more again.
Different context, yeah. Twice, but they're going to use the word something else. Like they're going to use twice more. See what I mean in context?
Yeah.
So, or twice less or something, whatever they're choosing to try to trick you with.
What did you write under twice?
Just sorry, triple. I was writing triple.
Okay.
Just things like that, quadruple, double. Does triple have 2 P's in it in the middle? Has 1. Doesn't look right when you put 2 in there. Okay. What about division? Division will be the last one. You could have something like the phrase a fraction of. Anything else? Yeah?
Each?
Each?
Yeah.
Each. Sure. Okay. So if in the context of they each have, I don't know, like two, I don't know. Yeah, three marble. Like I'm just thinking if there was a total assigned, you could have like one has two and one has five or something like that.
Or if you wanted to like say you have like 18 marbles and there are 6 bags, each one has like each.
Yeah, yeah. Okay, so yeah, so the word. Okay, I see what you guys are saying. So the use of the word each, with some context, kind of starts providing some fraction in your head, right, or divisions. Okay, that's a pretty good list, and we can add to it. You can always add to it as you start doing word problems. If you see some that you know mean certain orders of operation, you can add them to your list. Okay. So when we come down here, okay, the problem with word problems is they're no longer, when you come up with the two equations, they're no longer just x and y. Word problems have provided context to what x and y are, specifically to the word problem. So when you do word problems, you have to write let statements to tell me what are you saying x is and what are you saying y is, so that when you solve for them, there's some context there. Does that make sense? Otherwise, they're just a point of intersection. It doesn't mean anything. They're just two numbers on a page. But you've given me a number to represent something in a word problem, which means something. So you have to tell me what x and y are. That's what the let statements are doing. Okay? Does that make sense? This stuff can be a little bit tricky, okay? To know what to do when and how to like navigate these kind of word problems, okay? So just as a disclosure, okay, we'll put okay, you need to be specific with your let statements. Okay? So I'll let you write that down and then we'll start the first question. Okay, hopefully, so we've got 4 more lessons after this one, and each of them are just word problems, different kind of words problems. Yeah, read it. Oh, did you do the question right?
Huh?
What'd you need?
I just have a question.
Yeah, sorry.
In like word problems, is there a specific way to determine like if you have to graph it x and y, or can you just choose? Because like wouldn't that be like the dependent? And, like,
Yeah, the dependent and independent, yeah. Sometimes with the word problems, it's kind of, they represent two different things. Like for instance, when we do the money and mixture questions, it'd be like a bunch of change in a pile. X might represent the number of dimes, X and Y might represent the number of nickels. So there's really no dependent independent variable there. You know what I mean? But you got to specify which one you're going to talk about at the end. You know what I mean? When you get a number or like a point of intersection sort of thing. But you're right. Typically, the dependent variable goes on the. What did you say? Yeah, what did you say before? Dependent goes where?
Oh, I didn't specify where they go, but would independent be x? And
Yeah. I wasn't sure if you said the opposite.
No, I didn't
Yeah.
say either.
Sorry. I was just making sure you didn't say that, just to clarify. Okay. So everybody good? As we look at the first question here, okay, so you're going to try and write a system of equations that ultimately you're able to solve, okay? We can choose to solve it later, okay, if you want to. That's basically what we're going to do for the next 4 lessons after this. So the point of this lesson is, can we come up with let statements, and can we write the equations to represent the words that we've read? That's the point of this lesson, okay? from there, you can choose to use substitution or elimination to solve the questions, right? But the point of here, this is we need to come up with the equations. That's the heart of being able to do this, okay? So you're going to want to write a system of linear equations. That means two equations for your purposes, okay, to represent the situation, okay? So as I read through these, you might choose to do this as well. As I start to see words that I know represent certain things from my list up here, I might choose just to scratch them out and make it plus. The word is, to me, is equals. Okay? The word difference, subtraction, equals. Okay, so by doing this, I've kind of like made it less jumbly with words, right? And then I've started to put some math symbols in there. Okay? Now, you're going to write two let statements here. These ones are pretty straightforward. Anytime you have the two number questions, one of them is going to be let x represent, you could say even get like be specific, right? The bigger number. And let y okay. The let statements I find them a little bit tricky. Sometimes I come up with the equations and then go back and do the let statement second. Okay, there's no specific order, I think. Okay, but it's important to define what it is you're solving for. That the underlying that's important. Yeah.
So what you're saying basically is if you were to find the two numbers and then say let x be this number and let y be that number, that would be fine.
I suppose, yeah. I can't tell when you've written the let statement. You know what I mean? If you were to,
write it before, does it not?
no, I don't know when you wrote it, right?
I'm asking you, what do you prefer to do? Do you care when we write it or no?
I mean, it's probably good practice to kind of define them before you started the question, right? But there's no way for me to know if you've done it after. It can be hard sometimes. You know, when you find the numbers, when you actually find x and y, and you start to think about it, then it makes a bit of sense. Then you can put it together in your head which one's which. You know what I mean? Like we're gonna do distance and time questions. You know, the time number is gonna be sometimes small, well, should be smaller than the distance. You know what I mean? So by the time you've done the question, you know which one's which. You know what I'm saying? Which could be a little difficult to come up with at first, but sometimes you select the variable, like there's less ambiguity in the variables that you select right from the very beginning. Like in your distance time questions, like you're going to say let d represent the distance and let t equals the time. You know what I mean? Some of them are harder than others. Okay. So with this, now I know what the two variables are that I've selected. One's x and one's y. You can go back to your word problem now and say, okay, well, all I have to do is insert my variables into my sentence. So in theory, I should be able to just go like this, right? You see what I did? Just kind of went back and I was like, okay, well, on either side of the order operation, I should probably have a variable, right? And it's telling me the sum of two numbers, so x plus y has to equal 12, 11. Right? So that's one of your equations, right? You go x plus y is equal to 1,211. Then in the second part here, it says, and their difference is 283. Okay? The other thing I try to do sometimes is we get bigger word problems. If you see a period anywhere, like in the sentence, to break it up for the question, I always just kind of like draw a bar separating the halves of the question. Where I think I can come up with one equation and where I think I can come up with the second. Okay, and this one, it's the word and is kind of that pivot point where I can draw the bar, right? Where I'm like, okay, well, from the first half of this, I can come up with one equation, and from the second half of this, I can come up with the second. Okay? This is my process. If I get a new problem and I can't, because these can be hard to visually like come up with equations like this. This is kind of my go-to process that I go through, okay, to try and at least come up with the equations. Okay? Is everybody okay? It's at this point that you could, that looks relatively easy to solve, right? Like you could use elimination on that. You could add the two equations together, eliminate y, and solve for x. That would be the first number, and the second number would be y, right? The smaller one. You could just go through the motions that we've been working on for the last few days, okay? Again, that's not necessarily the point of this lesson. We're going to do that anyway once we start doing these questions. We just want to be able to come up with these things and the let statements. Okay. Remember, just writing these two equations down doesn't mean anything, right? Like it's just a system of linear equations. It's your let statements that ultimately define what it is you're finding. Okay, so I would still say the equations are a little bit more important because they allow you to do the whole question. But if you get to an answer and you can't contextualize what that answer means, then it's useless. You know what I mean? You've done all this work and you can't answer the ultimate, like what you set out to find. Make sense? Okay, so they're just going to kick up the notch, and we're going to do 4 different styles of questions. Okay, and I'll try and navigate you through these. Okay. Okay. So again, these are kind of, this one's relatively easy to come up with the let statements, right? So the athletic department bought a total of 29 basketballs and footballs at a cost of $1,000. There should be a little dollar sign there for you, if you're a stickler for that. Okay. If basketballs cost $30 each and footballs cost $40 each, how many basketballs and footballs were bought? Okay. So you could say, doesn't matter which one's which. You could say right from the get-go here, you could say let X represent okay, and then you could say let Y represent okay. There's really no right or wrong. You could make either of them X or Y. It doesn't matter, right? The point is when you go get the point of intersection at the end, if you reverse what you solved for, now you've told me the wrong number of each kind of ball. You know what I mean? Whereas if you define them from the very beginning, you're not going to mix them up once you get like a point of intersection. That make sense? Yeah.
Would it not make a difference if you were to say that Y was a basketball and X was a football?
Yeah, that's what I was just saying. What I was saying though is like at the end of the question, you're going to get an X and Y. If you don't if you like mix it up, the numbers, now you're going to tell me to buy a different number of each of them, and then it's wrong. You know what I mean?
But what if you said from the start?
From the start, it wouldn't matter. But I'm just saying, like, if you went through the question and then like didn't define them from the beginning, and then told me the opposite, you know what I mean? Whereas if you define them from the beginning, you're not going to make that mistake at the end. Okay. So now we come up with the challenging part. We got to come up with the equations. Okay. I see a period here, so I'm gonna like. This is just my kind of like. For me, I like breaking things into pieces. Okay. I'm gonna try and come up with an equation from the, like before the first bar there. Okay. So I don't know if I necessarily have the greatest way to like convey this. It just kind of is what it is, right? So if I buy 29 basketballs, sorry, it might be the,
Isn't it 29 total for basketballs?
oh, you're right. Sorry. Yeah. Okay. So here's a little other side fact which we'll use later. When you go to buy things, when you go to the cash register or something, right? You have $1,000 to spend, right? You have $1,000 in that, like, how many or how much of something you can buy kind of depends on what. How much that thing costs, right? That wasn't really a great wordy question. Yeah.
Wait, for this specific question, isn't there more than one answer for how many footballs and how many basketballs you can buy?
Not for $1,000, I don't think.
See, you couldn't get to $1,000 more than one way, you're saying?
Not if you include the price. I'd have to think about that.
How would you write the equation? Like, you could say 30x plus 40y.
Okay, good. Yeah, that's the harder of the two.
So
Now,
how would you specify that you're only buying 29?
so you're gonna say, okay, there's two kinds of like you got basketballs and footballs, right? And we've said that X is one and Y is the other. So when you add them together, they must equal 29, right? So I'll just write it down, then we could talk about it. So your first equation is going to be X plus Y, right?
29, yeah, that makes sense.
Okay.
And then 30x plus 40y.
That's what I was trying to. That's where the ambiguity was, because I wasn't explaining that very well. Okay. So obviously you can buy 29, or it tells you you can buy 29. How many of each kind of depends on something else, the price. But you know that when you add the number of basketballs that you bought and the number of footballs that you bought, it has to equal 29. Right? So that's that equation. The second one starts to incorporate the price, is what I was trying to get at. Okay? So in the second part here, it tells us that it costs $30 for basketballs, which remember are the orange, right? And then the footballs are the Y's, right? So if it's going to tell us the cost, it's $30 for the basketball. How much you're going to spend is the $30 times how many of them you bought, right? So we're going to multiply 30x, right? That's going to tell me how much money I spent on just basketballs, right? And then the second part of this is I had $40 for the footballs. That's going to tell me how much I spent on footballs, right? The total amount of money that you're allowed to spend is 1,000. Okay? Is everybody okay? So right from there, then you can just go, you can just solve it, right? Tell me how many of each you bought, basically, is the gist, right? And you write a therefore statement. Therefore, I bought this many basketballs and I bought this many footballs.
We're not going to solve it.
No, we'll do that later. We'll get more practice doing the actual solving bit later. We'll see all sorts of these questions. Remember, we've done lots of practice on substitution elimination. That's not the point. The point is, can we come up with the equations? And on the test, I'm going to give you a sheet that looks like this. Okay? Or something to be like, each one of these will be half a mark, half a mark. I think there's 6 of them or something. This will be the test on Monday. Right? And then you get a mark for each equation. There'll be 3 marks for each of these. Times, I don't know, I think I put 6 of them on there. Okay, so just trying to emphasize, can you guys come up with let statements and the equations? That's the important part. Okay. Is everybody okay? These can be tricky. Make me think sometimes. Okay. But again, I always resort to, you fall back on these two things, right? Like breaking the question into parts, okay? And then substituting words for mathematical operations, okay? So in A, or number 1 here, we kind of did this already. You could say X is the bigger number, Y is the smaller number. Okay? And then in the first equation, you know the sum of the two numbers, X and Y, is equal to 255, right? So X plus Y is equal to 255. The second one says when the smaller number is subtracted, remember the smaller number is Y, so the result is 39. So X minus Y equals 39. Okay?
Wait, just do if you're to make bigger as like one of like these things, which side would you put it on? Like like the
Oh, I see. I see. I didn't know what you were asking. This, okay. Have you ever heard like the alligator analogy?
yeah, like it depends what side you put the number on, but like what if you're using like the bigger number, which one would like
In the context of this question, it wants to eat the bigger number. So in this case, X. Is that helpful? That's just the context of this question. If I wrote a number here, it wants to eat the 50 over the 1, right? Does that answer it?
not exactly what I asked, but I'll ask you.
Okay. You can I don't know. Yeah, I'm maybe not clear on what you asked. Okay. If we do like a perimeter question, so we're dealing with shapes now, right? You could say the perimeter is 40. And it's 2 meters longer than it is wide. So it's talking about lengths and widths, right? Determine the dimensions of the rectangle. So you could say, you could use L and W and not worry about anything, right? It's just, they're trying to get you to use X and Y. It doesn't really matter, okay? So you could say X is the length and Y is the width, okay? I'm not too picky. I would have probably personally even used L and W, right? To be honest with you. And then when I wrote my equations, that would have involved L and W, right? So you could say, what's the perimeter of any, like a rectangle?
2 times L plus W.
Okay, so 2 times L plus W, right? And that comes from, just so everybody's clear, L plus W plus W. That's how you get all the way around a rectangle, right? And then you can combine that into, there was 2 L's there plus 2 W's. That's equal to the perimeter, but what's this thing tell you the perimeter is in the question? Like what's the perimeter of this particular rectangle? 40. So there's your equation, or one of them. Okay, and then the second one, it tells you that it's 2 meters longer than it is wide. Okay, so the width it's the other way. It's 2 meters longer than the width. So the length is equal to 2 plus W. Is that okay? Okay, you just keep going through these, and these kind of get a little bit more complicated, but it's just words with orders of operations, right? Like you're still gonna like, okay, we'll break this into pieces, right? That's always my first go here, and then I'm trying to like figure out what to do where. Okay, you could say in this question, you could say the number. Okay, and then this will be okay. So a publishing company in Ontario mails 1,040 brochures promoting a new university textbook. Okay, so it told you how many there were in total. Okay, this is like our number. Like what question we do up here? It's like this question. B. Told you a total number of something, right? There's two options. Okay. One of them there's most of the time there's like kind of an easy equation and then there's a harder one to come up with, right? In this one, you know there's 1,040 brochures that have been mailed out. Okay. And then later on in the question, it tells you, okay, well, some went to North America and the rest went to somewhere else. Those are your two options. But when you add the two options together, you know that there has to be 1,040 brochures mailed out. So X plus Y has to equal 1,040. Okay. The second part of this looks like kind of a money question again because I see some dollar signs, right? And so it's 46 cents to mail within North America, which we said was X. So 0.46X plus 48 cents to mail elsewhere. And the total that they spent was $483. Is that okay? Am I doing an okay job of like breaking that down? This for the first time, like this could be very, very difficult. Okay. And there are times where I'll probably come around today to help people with questions and not be able to do something just because of something silly in your head that you just got to break down, right? Okay, there's always like kind of one easier equation than the other. And I think you can see how once you get the easier of the two, right? The other one's kind of like, it's like a sister equation, right? It's kind of similar in the way that it's operating. You're just dealing with something else. Does that make sense? Okay. So I see two different things here. Number 4, I see hamburgers and slices of pizza. Okay, I'm going to keep reading though. You get $1 change back from a $20 bill if you buy 8 hamburgers and 2 slices of pizza. You get 50 cents back from a $20 bill. Find the price of a hamburger and the price of a slice of pizza. Okay. So this one can be like, there's a little bit more going on here. Okay. Because we're purely in dollars. So you're going to want to, ultimately you want to figure out, well, how much is the price of each, right? So you're going to say, okay, well, I suppose as we start doing more of these and I do more of these with you, sometimes the very last part of this question kind of sets up what your let statements are going to be. Does that make sense? So there's not as much, I guess, confusion around the let statements as I maybe initially thought, right? If you read the entire question all the way to the end, find the price of a hamburger and the price of a slice of pizza. If that's what it's going to ask you to do, you better set up your let statements to appropriate that, right? So X is Is that okay? Then from there, you're like, okay, well, I got two instances. I go to two different places, I guess, right? Okay. You're going to give a $20 bill. You're going to buy 7. All you've done is change what the variable means. So 7x plus 3y has to equal, here's the sticky part, you get $1 back in change from a $20 bill. Okay? Which means it costs you $19, right? And then in the second scenario, I'll clean this up a little bit. The second scenario, you're going to buy 8 hamburgers and 2 slices of pizza, and you get 50 cents back for a $20 bill. Okay? So 8x plus 2y is equal to 1950. Okay? And then the last one, is everybody okay with that? Okay? They just keep adding words and words and words. Sometimes the words start to they're trying to throw you a wrench. The more words you put in there, you're like, okay, it's too much information. You know what I mean? So as the owner of a banquet hall, you're in charge of catering a reception. There are 2 dinners, a chicken dish that costs $16 and a beef dish that costs $18. The 300 wedding guests have ordered their meals in advance, and total cost to prepare the dinner is $5,256. How many of each type of dinner are you preparing? Okay, so this might be like, I probably should be at this stage by now, like the marriage stage, I mean, because I've been with my girlfriend for 10 years. But if we were planning a reception, right, am I going to sit there and count all these RSVPs? Or am I just going to like figure out how many of each there are?
You gotta be exact. You gotta spend the time.
I gotta spend the time?
You put in the time.
You know what I'm saying though? Like, do you want to sit there? It might not take you that long, to be honest with you. I'm just trying to like relate this to real life here, okay? Are you gonna sit there and count 300 RSVPs and like figure out who ordered how many of each, or would you like to do a little bit of math in like 5 minutes, 2 minutes?
Nobody likes cutting corners.
Nobody likes cut. What do you want to do, Paul? You want to sit there and count them all? Okay. Yeah, I suppose. Two summers ago, I went to a wedding with like friends of mine got married. They had 500 people at their wedding. It was like it was like a hockey. It was bigger than a hockey arena, like a rink, right? The reception hall, and there was just people everywhere. It was just madness, right? Anyway, Paul, maybe not the best relation to real life, but I tried my best here, buddy. Right? Okay. We'll do some more that are like more realistic, but this is just entry level. Get you into some word problems, okay? So that's the idea. You can either sit there, count all 300 and count up who did what, right? Or you can do a little bit of math and like figure out X and Y.
What's the math you would do?
Usually, just like you're gonna say, okay, let's just do the question. We're gonna say let X represent, I don't know, the number of like each dish, right? So X is gonna be the number of chicken dishes, right? And Y will be the number of, what was the other dish? Beef. Right? So when you get an answer, it's going to tell you how many of each there are. Right? You know that 300 wedding guests have showed up. So X plus Y, you know the number of dishes. Everybody's going to eat. We're assuming everybody's eating dinner. X plus Y is equal to 300. Okay? And then the second part, your second equation is a like total amount of money, right? The total amount of money spent on each dish depends on how many of each were ordered, right? So, but you know how much the final bill was. It's $5,256. So now you just got to figure out the left side. Well, how do we make dollars out of like the number and how much something costs? We just multiply them together, right? So chicken dishes cost $16, so 16x plus 18y.
But does this work like every time?
What do you mean? It's math. It must work every time.
No, but like I mean, like in the situation that you're doing like the football, right? You
Yeah.
can get a different number of footballs and basketballs, and you still get to $1,000. And sometimes you really need to see what they wrote to know how many they want. Like,
Yeah, I still have to think about. I still have to think about that question. But there's something. Like, remember what it is we're doing. We're solving for the point of intersection, right? But you're probably right.
It's like the way I looked at it is like you could get 20 basketballs and 10 footballs and you'll get to 1,000. But you could also get 32 basketballs and 1 football and you'll get to 1,000.
Yes. But maybe their needs were they needed both of those.
But how do you know how much they wanted each?
They probably defined that. I don't know. I'm speaking off the top of my head. I have to think about your question. It's a very good one. It's making me think. Is that all clear? So these are just word problems. This is like, I will give you a page like this of assorted word problems where you write, again, it's half mark, mark, mark. Okay, just coming up with the equations, not necessarily solving. You're wrong.
They specify how many you can have in total. So never mind.
That's the second equation.
Ah.
And that gives you context around the point of intersection. It's a unique point between two circumstances. How many balls you can buy and how much you've spent. Those are two situations that they cross. That cross point is a decision. Right?
And it's the same for like the wedding one. So you got a specific amount of guests and a specific amount of
Yes. So lines just represent situations. The point of intersection provides you the decision that you're going to make. Does that make sense? I'm trying. We'll keep trying. Okay? So I'll give you some of these to practice.